Good evening. So I'm going to start with a question because who doesn't love audience participation on a Thursday evening? So by show of hands, how many people here work for a data-driven organization? Okay, that's pretty good. And by way of shouting out, what kind of metrics do you guys monitor? So stuff like revenue, sales, that kind of stuff. Sales. Anything else?
Conversion rate.
Yep, conversion. Churn. Anything else? Revenue. Yeah, revenue is a big one. So at ClearScore, let me just tell you a little bit about the business. We provide people with their credit score and report completely for free. And like any good fintech startup, we have data coming out of our ears. And we monitor all those kind of metrics. So the revenue, the churn, the engagement, the acquisitions, the sales, the NPS, the NPV, the CPU, all of the key metrics which we're supposed to monitor. But what we don't really do is look at our customer operations data. We have a lot of data that we collect, but we really don't use in any sort of aggregated, automated way. And we're a user-driven business. Without our users, we have nothing. So it really doesn't make sense that we've got all this data sitting in tickets whenever our users write to us that we're not looking at in any kind of meaningful way. And our customer operations team, they, much like every other team in the business, they are data-driven, and they have their own key metrics which they look at. So inbound tickets and outbound tickets, time to first response, time to resolution. But there's no real automated way of looking at what our users are actually saying to us and how they feel about it. So as a data analyst and data scientist, I decided I wanted to do something about this. So I decided to run a hackathon for all the analysts. I got them all into a room for a week. It was not compulsory, I promise. And I said, we're going to look at this customer operations data, and we're going to see what we can do with it. We had two key projects that we wanted to focus on. So the first was predicting customer satisfaction ratings. And the second was trying to forecast users who were going to turn into a complaint. And we brought in data from all around the company. We looked at the ticket metadata, and we looked at their behavioral data, and their report data, and their account data. And we decided, you know what? This is a data science hackathon. So we're also going to do some text-based analysis on the tickets that they write to us. And this will be a nice little feature. We can just use a standard Python package. We ended up using TextBlob. And we'll get a sentiment score, we'll get a subjectivity score. It'll be great. Now that's what I actually want to talk to you about today, because unsurprisingly, for anyone who's done any sort of text-based analysis, it really wasn't as simple as I've just said. In fact, it was pretty complex. And there were definitely a lot of improvements that we could have made, but it was a week-long hackathon. So I said we used an off-the-shelf package called TextBlob, and the early results, when we first ran the ticket data through it, it was pretty good. So these are a few examples of tickets that we got. So I'll read them out for the people stuck around the corner. So the first one, an excellent service, been using this app for a while now and improved my credit rating. Well done, folks. And this got a sentiment score of 1, which means it's incredibly positive. In fact, it's about as positive as you can get. And when you think about the message, it is positive. There is nothing negative about it. Then you look at the next one down, 59.9% APR. Are you bonkers sending me this? What moron would take a loan at that rate? The answer is someone who can't get a loan at a better rate, but there you go. And this got a sentiment score of minus 0.9. And that's kind of understandable, because it is inherently a fairly negative message. This user is frustrated and they are confused. But if you look further down the list, you actually start to see where the model falls down. So the third one is, my score here is around 270, but Experian have me as excellent on 467. Now this isn't a particularly positive message. It's not particularly negative, but it's certainly not positive. And yet the scorer has given this a score of 0.97. So the scorer is saying, actually, this user's feeling pretty good about us. And we look at another message. I noticed the balance on my Barclays card and Tesco credit cards are incorrect. I will be very happy if my account can be updated accordingly. Again, it's polite, but the user's still not particularly happy. You certainly wouldn't say, this user's jumping for joy. And yet, this gets us a score of 0.75. And this was actually a fairly common thread. We were seeing the scores which were graded negatively. You read through them and you go, actually, yeah, this user's clearly pretty frustrated. But we were also getting a lot of false positives. And it really wasn't hard to figure out why when you look at the individual messages. And the answer is because English is a pretty weird language. As I'm sure anyone who has ever tried to learn it as a second language or a third language, you'll all be pretty familiar with that. So to give you a few examples, this is a standard message which we stuck through the scorer. Good afternoon. Please could you explain why my credit score is only 320? On Experian, I have an excellent score. I have a perfect payment history on my mortgage. This makes no sense. All the best. So again, a polite message, but the user's not exactly what you'd call happy. And yet it gets a great score through the model. And you sort of think about it for a bit, and then you're like, you know what? This really reminds me of someone who doesn't speak a word of English, and is pretty much just standing there with an English as a foreign language dictionary, trying to read it word by word, which, if you think about it, is exactly what a machine learning model is pretty much doing. So if you see it through the machine's eyes, what you're basically getting is, good afternoon. Good, we're off to a start. That's a positive word. Please, user's polite, it's looking pretty positive. Could you explain why my credit score is only 320? On Experian, I have an excellent score. Excellent. We're in the green here, guys. I have a perfect, even better. Perfect is about as good as you can be. I have a perfect payment history on my mortgage. This makes no sense. All the best. Guys, they said with the this user's got to be really happy with us. And so, as I said, we were only doing this hackathon for a week. We didn't have time to endlessly optimize the model, not least when you consider this was supposed to be just contributing a single feature to our other project. But there were a number of things which we were able to do to help improve the scorer. So the first was keywords. Now we had two lists of keywords. The first had very strongly negative words which were associated with the user being really unhappy. So financial conduct authority, or ombudsman, or complaint, or official complaint. And these all indicated that a user was feeling really negative. And then we had a secondary list, which had a few negative words and a few which weren't inherently negative, but which gave a sense of urgency and maybe suggested that the user was feeling pretty frustrated. So words like unacceptable, or shocking, or ASAP, as soon as possible. And what these did was they essentially formed a way to overwrite the sentiment score. So that if you had a message which had a bunch of negative words and a bunch of positive words, and the scorer didn't work so well on it, you could use this to say, actually, it's also got a bunch of those negative terms, so we'll assume it's a fairly negative message. We also worked on trimming out the header and the footer. So, as I said before, the English language really sucks when it comes to machine learning. And you look at a lot of greetings, things like good morning, good afternoon, good evening, or, the sign-offs, the all the best, kind regards, that kind of stuff. And they're phrases which aren't inherently positive or negative. I mean, they're polite, but, they're not really sentiments one way or another. Yet they're made up of individual words which are themselves positive. So by taking those out, we can make sure that we're focusing on the main body of the text, the message that the user is actually trying to convey. And we were also able to strip out some of the signatures. So this is text which quite often the user isn't even writing. So sent from my iPhone, or transcribed by Vox services, or this email has come from a third party and may contain confidential information. Please do not pass on, fail to open any attachments, that kind of thing. And the reason for stripping out those is, while they're not inherently positive or negative, they might not get a particular score by themselves, what they do serve to do is dilute the original message and just drag that sentiment score closer to 0. And finally, and this was one of my favorite parts, we had the expletive counter. So we all sat in a room at 9 p.m. thinking of all the swear words we could So we could stick in an expletive counter and an expletive density counter. And this is pretty good, because some of our users are less than polite when they write to us. They don't always realize that it's a real person reading these messages. And when you're talking to a third-party organization, while you might swear pretty freely with your friends, and it might be pretty positive when you say that, it's generally strongly indicative of a negative message if you're swearing when you're writing to a company. So that was pretty good. But there are also a number of other things which we've continued to work on post-hackathon as we try to push these models out into production. So the first is more expletives. And the reason for that is it was a very standard list that we used. But, you know, we've got users all over the UK. And the Scottish and the Irish, they all have their own particular way of swearing, and it's wonderful. But you've got to make sure those are also included. And that brings me on to another point about language, which is that we're present not just in the UK, but also in South Africa and India. And those are countries which do speak English, but they don't really speak British English. They use their own phrases, and they've got colloquialisms and idioms, and you cannot train a model on British English and expect it to work perfectly for places like Cape Town and Mumbai. In fact, you couldn't even train data across all three of them and expect the model to work perfectly across all three of them, because you start to end up bringing in a lot of bias into your model. So what we'd actually end up needing to do is to train individual models for each of those three markets to really try and eliminate that bias. The second thing we'd want to do is get in more data. It was quite costly, time-wise, to bring in the data for this hackathon. So we only actually had about 200,000 tickets that we were working off. So we'd want to make sure we had more of those. And finally, and this is a really tricky one, which I think is you know, it's very hard across machine learning, and that is sarcasm. And this is you can tell this is going to be an issue, because anyone who has ever learned English as a foreign language, quite often they do struggle to get this. And how do you explain to a machine that, you know, you've got negative sentiment gradually increasing to positive, and then it gets to a point where it's so positive, so enthusiastic, that actually a human can tell that means it's rubbish? I mean, it's what do? You know, there's a certain level of enthusiasm within the message, and so much of it is context-based, or there are certain phrases which are a giveaway, but sarcasm is a very hard thing to encode. So that's a kind of brief summary of the sentiment model. Now I just want to go back to what I was talking about at the start of the talk, so the idea of key metrics. Because while the sentiment model is useful as a feature within other models, it's also pretty useful in its own right. Now, why is that? Well, for one thing, it enables us to quantify our feedback. Now, our customer ops agents, they read through every single ticket, and they do compare notes. But at the end of the day, one person's threshold for this person feels positive or this person feels negative is going to vary person on person, and it's going to vary over time. But by having a more objective way to look at this sentiment, you know, it's something which we can reliably track. It also helps us to prioritize better. So it means that when you get this kind of model in production, when someone sends in a ticket, we can see straight away how positive or negative they're feeling. And in doing so, it means we can get to the users who need our help most as fast as possible. But finally, it opens up the idea of being able to track sentiment as a key metric. Now, a lot of organizations will look at stuff like retention and churn and account deletions as a way of tracking how positive or negative their users are feeling about their product. But when you really think about it, it is pretty crazy that you are willing to wait until your users, your customers have left before you actually decide, actually, this is an issue and we need to do something about it. Whereas by tracking sentiment, by ensuring that when our users take the time to reach out to us and contact us, we're able to track that sentiment and we're able to see that they're starting to feel more negative about it. We can make sure that we are there, that we're ready to listen, that we're ready to hear them, and that we're ready to change. And that is ClearScore sentiment model.